everyone, so I am joined by Jakob from Noctua again, and we just shot a video about a beat frequency Schwebung phenomenon. Very interesting stuff. This time we're going to talk about something, though, relating to bearings. And so bearings, I think, if you were to just kind of follow purely the marketing, then there's a very rigid, defined hierarchy of like FDBs at the top. You can't get better than that. And then, sleeve, rifle, ball are all sort of down here somewhere, and some of them we're not even sure what it means. In reality, is much more complicated than that. So that's part of the topic. And you've also brought with you a ton of pieces of bearings.
Yeah.
So how do you want to jump into this topic of fan bearing differences?
I think it could be nice to first just clear up some of the misconceptions that are floating around, especially when it comes to that hierarchy and I would say FDB bearings in general.
Before that, this video is brought to you by Thermaltake and the Tower 300. The Tower 300 is a full-on showcase PC case built to present the computer straight on with its angled tempered glass windows or on a unique mounting stand to show off the build in new ways. The Tower 300 has a layout that positions the GPU fans against the mesh panel with ventilation on the opposite side for liquid coolers and CPUs. There's also an included two 140mm fans up top. The panels use a quick access toolless system to be quickly popped in and out for maintenance, and you can learn more at the link in the description below.
From a technical perspective, it's easy to distinguish ball bearings and sleeve bearings. That's a very straightforward distinction no one can really argue with. But what actually makes an FDB or HDB bearing is not as straightforward. A lot of people have those herringbone grooved bearings in mind, so it could either be the shaft having a herringbone or spiral groove inside, or the bearing sleeve. But the name fluid dynamic bearing as such only says that there is a dynamic pressure field on the fluid. And that's exactly what happens with any lubricated sleeve bearing as well. From a technical perspective, first of all, FDBs and HDBs, I would say the terms are interchangeable because hydro is just water in Greek, or fluids in Greek, and fluid is obviously fluids in Latin. So I would say these mean the same thing. And if companies try to distinguish between the two in marketing, it's more like a marketing endeavor than a technical difference. From a technical perspective, fluid dynamic and hydrodynamic bearings are sleeve bearings. If you say, okay, what I mean by FDB is that it has that herringbone or spiral groove, that's a different story. Of course, you can make that distinction. But even then, I think it's important to understand where this structure comes from. I mean, the basic concept of adding grooves to enhance lubricant circulation is very old. Like this dates back more than 100 years. 19th century early trobology experiments by Reynolds and so forth. So this is very old. And then we need to look back into the 80s and 90s when a lot of the so-called FDB patents were filed by companies like Matsushita. But the background of these patents were hard disk drives.
Oh, okay.
And when you look at the hard disk, usually it spins at least 5,400 RPM, and the disks themselves are super rigid. So you have an extremely high load transfer to the bearing.
Okay.
And of course, the FDB bearings have been introduced to fans as well. But the question is, what benefit do you get out of them in fans? And I would argue that it's not as simple as looking at them and saying, oh, they have grooves, so they must be better, right? Of course, the grooves, they enhance fluid circulation and pressure build up. But the question you should ask is, does your application require that?
Okay.
Does your application benefit from that? And in what sense?
So what are, let me interrupt for a brief second here, but if we take a computer fan, generally speaking, broadly speaking, a computer fan, what are some easy examples of real advantages? Things you think are real advantages to one type of bearing over another. So not necessarily just like the advantage of FDB, because like you've said, it's not always the best. But generally speaking, if we say a couple common ones like ball and FDB.
So I mean, I would say that the main deciding factors for bearing selection are temperature stability. So you should know what temperatures your fans are running at. Of course, it's lifetime, and it's acoustics at the beginning of life and over time. So how does the bearing sound factoring you, and how does it sound after a couple of years?
I forget which one it was. I remember studying a long time ago bearing differences, and there was one that was described as when it fails or starts to fail, it makes an increasingly higher pitched, like almost screeching noise.
Yeah.
As it kind of runs towards end of life.
The load bearing capacity, of course, is another key factor. A rule of thumb that you could throw out is that ball bearings are better at higher temperatures. So if you want to go, like, let's say beyond 70-degree operating temperature, a regular sleeve bearing is not gonna cut it. This is a point where FDBs actually, or if we assume that FDBs are those with the groove, right?
Yeah.
Actually do have an advantage, because the extra fluid circulation you can create with the grooves enables you to use higher viscosity lubricants.
Okay.
And the higher viscosity lubricants can be used at higher temperatures because they don't dissipate as quickly when you run high temperatures.
If you had your way, in terms of if you could snap your fingers and make the whole world use a certain set of phrasing, I mean, would you rebrand FDB as it's known in the industry?
Yeah, totally.
So what do you feel like would be?
Because I would say that any self-acting lubricated sleeve bearing is a fluid dynamic or a hydrodynamic bearing, because the capillary forces pull up the oil into the gap between the shaft and the bearing sleeve, and the spinning of the shaft creates a dynamic pressure field. So that constitutes what the term describes.
Right.
So
how would you rebrand the industry's version FDB, meaning like with a V groove or whatever other type of groove?
The herringbone spiral groove bearing or something like that.
Sure. Okay.
And I think it's also important to keep in mind how many different versions of this are out there. So it's not like, at least as far as I can see, that there's this single archetypal FDB patented by Matsushita or some other company. It's like dozens of them, and they all protect very different approaches. It often has to do with fluid recirculation. So what's often patented is things like bores going in radial direction or axial direction for fluid redistribution through the different fluid reservoirs the bearing has. But none of this, as far as I can tell, has ever been used for fans.
Okay. So what about bearing structure, just to kind of like familiarize everyone with the basics?
Yeah, I mean, so the basic parts we've already been speaking about is obviously the shaft or the axis of the fan and the bearing sleeve. This is like a section view of the fan sitting like this. We can add the impeller, so airflow would be this direction.
Okay.
And we can see the outer bearing shell here. We have it in brass inserted in the injection molding process for our high-end models. Inside the outer bearing shell is the bearing sleeve. We have the axis or shaft going into the sleeve. Then there's the part I forgot to bring, namely the lock ring. You can see it here that locks the axis underneath the sleeve, so that this piece, so that you cannot accidentally or intentionally pull out the impeller, because one of the key critical factors for bearing life is avoiding contamination. So our bearings have a ultrasonic welded oil seal sitting in top that prevents the oil from going out and any contamination from getting in. Sometimes we get the question, why don't you make those impellers removable? It would be so nice for cleaning. It would be nice for cleaning your blades, but the risk of contaminating your bearing and thereby shortening your fan lifetime would be quite high. Yeah, and then in our case, we also have a magnet on the rear side of the fan, a little plastic magnet holder the magnet is already inside the holder here, a buffer or wear disc that prevents the shaft from wearing the magnet holder. Yeah, that's the basic structure of our SSO bearing. For us, the magnet is obviously a vital part because we already talked about those dynamic pressure fields building up when the shaft is rotating. It takes a few fractions of a second, we're talking like a few tenths of a second, but still, for those pressure fields to build up, even if you have those FDB herringbone grooves. The beauty of having a magnet inside for extra axis stabilization is that we have that stabilization from the get-go.
Okay.
And that reduces the initial gyro effect on the fan that actually is quite critical from a wear perspective.
How much should people care about the bearing in their fan? Because this I'll tell you from the media side. You're on the manufacturing side. The media side, it's whenever someone has a new fan to announce or talk about at a show, some of the things you're familiar with on Noctua as well, but things like distance from the blade to the inner wall of the housing. But I would say the number one thing that's marketed is bearing, and it's always FDB. No one seems to, and not like a specific herringbone groove FDB, but just FDB. So it seems to me that the industry really at least wants people to care about this. How much should they actually care?
Well, I would say people should care a lot about their bearings because it's the heart of the fan.
Sure.
In a certain sense. It dictates the lifespan of your fan. But I would, on the other hand, be very hesitant about making too much of the terms on the box. So I would say you should look at the track record of the manufacturer much more than whether it says FDB, HDB, or sleeve bearing on the package, because it's so many factors that play into what makes a good bearing that are more important than the basic structure. Like it's pretty similar to heat pipes where on paper it looks so obviously that let's say composite heat pipes are superior to regular sinter type heat pipes. But we briefly spoke about this last year. I think you can a good regular sintered heat pipe outperforms a badly done composite one any day. And it's the same with bearings. You may have like the biggest herringbone structure ever, but it could still be an utterly poor bearing. So it's not like this basic structure will give you any information regarding whether it's a good bearing or not. There's so much. There are so many factors like surface finish of the components, tolerances of the components.
Like how good the seals are.
How good the seals are. How well the different materials interact. Like, is there any possible incompatibility between the lubricant and the seal, for example? That is very critical. Then you need to look at things like pore size on the different materials, both the shaft and the sleeve. Also viscosity of the oil. So it's so many factors that make a good or bad bearing that reducing it to is it FDB or is it something else is
reductive.
It's not only reductive, it's even confusing because just the fact that it has herringbone grooves doesn't mean much at all.
If Noctua is going to design a new fan tomorrow, what considerations might you have to make a decision on which bearing to use, what kind of bearing you want to use? So for example, pick any use case you want, any target customer you want. For that customer, who is the customer? And then for them, what factors might you consider for bearing choice?
Yeah, I mean, it's the factors that we already discussed before. So one is the expected load on the bearing, temperature ranges, operating temperature ranges, lifetime and acoustic requirements.
So when you say expected load, does that get into like fan size? So like a 200 millimeter fan, for example.
It does. Like for the 200 millimeter, what we did is that we increased the diameter of the axis from 3 millimeters to 4 millimeter in order to have enough support for that. But it also depends on RPM speed. Like the 200 millimeter is relatively slow spinning in our case. Like the fastest version we have is 1200. We're probably going to have a 1500 as well. That is still doable with the current bearing. But let's say we built a 4,000 RPM version of A12. Then we would need to consider a different bearing than SSO2 because the loads are so high. So this is a case where we would probably go for a ball bearing, because ball bearings are still unmatched when it comes to load bearing characteristics. And the same would go for temperature requirements. If we have an industrial customer approaching us and saying, okay, we need to run those at 90 degree constant, we would say, yeah, this is a case where we need to go for ball bearings because our SSO2 is specified for 70 degree maximum. I think that's not an issue for any typical PC use case, but
for a normal,
for industrial customers it may matter. And coming back to the original hierarchy question, that response could now prompt the follow-up question. So why don't you use ball bearings on all fans? They are superior, right? But they have acoustic penalties. They are louder in the beginning already. You can always hear those balls moving, and once the balls start to wear, they get even louder. So you only want to use that if necessary. And similar arguments could be made with regards to FDB, like grooved sleeve bearings. The key advantage of the grooving is that you can use higher viscosity lubricants. So that's something you basically only need if you run higher temperatures. And that's another example for, I would ask the question, in what sense is a bearing better and what for? Because, okay, that makes it better for higher temperatures, but the higher viscosity lubricants increase the time to no contact between the shaft and the bearing sleeve. So that time until that pressure field builds up is longer the higher the viscosity of the lubricant. You can also run into acoustic concerns with the lubricants, and all the groovings have the downside of adding additional complexity that needs to be controlled from a tolerance perspective. So if you happen to have those nice grooves and rough edges on them, this is something that will be audible. There's
a lot of factors, of course, and that does make it where the average consumer, I think I kind of point back towards, I don't like this answer generally for things, but I think I point back towards what you said of you look at the track record of the manufacturer to establish a base level of trust, basically, that they know what they're doing.
I understand it's difficult to have a blanket statement like this because, of course, manufacturers may use different bearings on different fans. That can be a thing, or they end up cutting costs and putting in cheaper stuff.
Yeah, I think it makes sense. What I was going to say, though, is I think there's also a few things you've said here that are somewhat actionable. So if someone is building something where maybe it's not an enthusiast computer, but you're going to have a high heat environment, right?
Yeah.
It sounds like there are too many factors to simply shop by bearing type as a consumer.
Definitely. I would say it's generally very difficult for customers to make an educated choice there, because what else could you look for except bearing type? You could look at the MTTF or MTBF specs manufacturers give.
If they're honest about them.
But there are so many different ways of establishing them that they are like utterly uncomparable. And you also see numbers floating around, like if you see like 300k hours on a fan, it's more than 30 years. And I'm not saying that this cannot be calculated, but the problem is if you take a, let's say, 3-4 month accelerated lifetime test and then extrapolate to 34 years, that's a lot of extrapolation. Like with any data you use to extrapolate, the further you go, the more
it'll deviate.
Uncertain the results will become. And this is why we still stick to this more than 150,000 hours specification, because this is something we're comfortable with. And we now have actually fans running for 17-18 years and knowing that they are running fine. But just going beyond that in specification seems a bit questionable.
Also, MTBF could be a specific part of the fan failure too, where it may not be the bearing, it might be something else. But as an example, we won't get into, but there was a series of fans from a vendor many years ago where I had two of them in my case, 200 millimeter fans, and they both had the blades explode. So small fractures formed, because the blade was, I guess it was too heavy or something. It was early 200 mils. And consistently, every single one of them in that case, eventually a blade exploded out of the fan. So, different type of failure, not bearings. Is there anything else on the bearing topic? Any other misconceptions you want to knock down right now?
I think we already spoke about the hard disk drive background and how this is like a completely different loading situation that's not necessarily applicable to fans. We already discussed at length that just the fact that it says FTB on the label doesn't necessarily make it a great bearing.
Right.
Yeah, I think we've covered the basic points.
Excellent. Well, we're 25 minutes over our allotted slot. And we didn't even get kicked out this time. I was kind of hoping we would, just make it a tradition every year. But unfortunately, we made it to the end of our conversation, and we haven't been removed from the room forcefully. So thank you for joining me.
Thank you. It's been a pleasure.
Absolutely. And check out the other videos on the channel. I'll link them below. Thanks, everyone, for watching. We'll see you all next time.